Welcome to the GOB laboratory at Mercy College. In this experiment, we'll take a look at how gases respond to changes in volume and temperature. In part B of this experiment, we'll use Gay-Lussac's law to predict absolute zero using temperature and pressure measurements. Here are some of the materials that we'll make use of in part B of this experiment. To begin, we first need to attach the gas pressure sensor to one of the available channels on the side of the LabQuest. Plug the temperature sensor into one of the other available channels. Tap the display to change the units from kilopascals to millimeters of mercury. Make sure that one end of your tubing is connected to your gas pressure sensor, and the other end should be connected to one of the ports on your stopper. Also make sure that there's a valve connected to the other port and that it's in the closed position. Firmly insert the rubber stopper into the mouth of your Erlenmeyer flask. The stopper needs to stay in place during the entire experiment. Now that your flask is sealed, be sure to record the pressure and temperature corresponding to your room temperature data point. Now add a small amount of near boiling water to your beaker in order to create a hot bath. Your target temperature is in the range of 55 to 60 degrees, so it may be necessary to add some room temperature water or a few ice cubes in order to bring the temperature down to the range that you're looking for. Try to keep the water level between 1/2 to 2/3 full so that there's still room to insert your flask. You'll want to stir the solution thoroughly until the temperature stops changing. Insert your flask into the beaker, making sure that the water level is up to the level of the stopper. Try not to handle your beaker by the stopper because you don't want it to pop out. Using your finger gently on top of the valve, push the flask up and down in order to continue to mix the water to make sure that we have a uniform temperature. You need to give enough time for the flask to equilibrate to the temperature of the bath. Once you obtain a stable pressure and temperature reading, make sure that you record those on your data sheet. This will be the hottest temperature, so we'll use this as our 5th data point. Now carefully remove the flask and the temperature probe from your hot water bath. You'll want to pour off most of the hot water into your waste beaker, but leave some in your beaker so that you can dilute it down with room temperature water for your next target temperature. We're now going to create a second bath with a target temperature of 35 to 40 degrees Celsius. We're going to do this by adding room temperature water and maybe some ice until we've achieved the temperature that we want. Be sure to stir the bath thoroughly until you've arrived at a constant temperature. If you need to, you can add more room temperature water, more hot water, or more ice. Again, carefully submerge your flask in your bath and move it up and down until the temperature has reached a stable value. When you're ready to record your pressure and temperature readings, try to hold the flask as still as possible, making sure that the water level is up to the level of the stopper. Again, carefully remove your flask and temperature probe from your water bath. Remember that if at any point during the experiment your stopper pops out of your flask, you're going to have to repeat all 5 data points again. Fully discard the warm water into your waste container to prepare for your first cold bath. Our first cold bath will have a target temperature of 10 to 15 degrees Celsius, so we're going to start with some ice and then add room temperature water to try to get just the right temperature. Stir thoroughly, and if necessary, you can always add more room temperature water or some warm water from your waste beaker. Be patient. It may take several additions to get just the temperature that you want. Again, insert your flask, making sure that the water level is up to the bottom of the stopper. Continue to mix carefully with an up and down motion of the flask. When you think you're ready to take your final temperature and pressure reading, make sure that you hold the flask as still as possible, and then record your pressure and temperature on your data sheet. Again, remove your flask from the beaker as well as your temperature probe, and pour most of the water into your waste beaker. To prepare your fourth and coldest bath, we're going to start with a generous amount of ice. The target temperature for your fourth bath should be between 0 and 5 degrees Celsius. Add a small amount of room temperature water and stir vigorously until most of the ice is melted. Once you've reached a stable temperature, insert your flask into your beaker and continue to move it up and down until the flask has equilibrated. To take your final reading, make sure that you hold the flask as still as possible, and then record the pressure and temperature on your data sheet. Now remove your flask and temperature probe from your bath and dispose of your wastewater. To analyze your Gay-Lussac's law data, navigate to the Desmos link provided in the description below. You should see the Gay-Lussac's law data table on the left, consisting of pressures and temperatures, where you can enter the data from your experiment. As you enter your data points, the live graph on the right will update. Below the data table is our linear Gay-Lussac's model. You see that it consists of a slope and a y-intercept, both of which we're going to adjust in order to get the best fit to our data. On the left, you'll see adjustable sliders corresponding to the slope, the y-intercept, and our pressure calibration parameter. The first thing that we're going to do is set our pressure calibration parameter to the same value that we used in part A of this experiment, since we're using the same sensor. Next, we'll adjust the y-intercept to get the best visual fit to our data. You can see that adjusting the y-intercept moves our model vertically on the graph. Now adjust the slope, which controls the tilt of our model, until you have the best visual fit to the data. Once you've selected the best values for these parameters, scroll down to see a prediction for absolute zero based on the parameters that you've chosen. Be sure to record your estimate of absolute zero and compare it to the true value for absolute zero, which is minus 273.15 degrees Celsius. If you use the graph controls to zoom out on the graph, you'll see that the absolute zero estimate corresponds to the x-intercept of our linear function.